So hello, my name is Norbert Sabo, and I would like to talk about how to do spatial computable general equilibrium modeling in GAMS. Okay, so now let's turn our attention to the simulation file. So I will open it, I look for the simulation file, and here we have it. So within the simulation file, we first start with the scenario switch. The scenario switch controls whether we are going to run a baseline simulation, which is a business as usual scenario, or we can run a scenario where we can introduce different kinds of shocks and interventions in the model. So when the scenario switch equals to 0, it's a baseline run, and when it's 1, it means that we will have some shocks in the system. And those shocks are going to be defined somewhere later in the code if we scroll down a little bit later. So first we have the numerator, which is price of, in this case, capital, which is set to unity. This price won't change throughout the simulation, so all prices will change in relation to this price. So this is what we meant by the relative price changes in the system. So that means that the CGA model usually cannot capture price levels and the actual change of prices in the system, just relative price changes. So next we have to define variables and equations, and then we have to define the actual form of those equations, like labor and capital demand, consumption demand, interregional trade, etc. So I don't really want to go into details of those equations. You can look up a standard CGA model and see how you can define those functions. In this case, the purpose of this video is purely illustrative. Okay, so now we have to define the model. This is called a CGE model. I included all the equations above, and I set the starting value of the variables. This will make it easier for the GAMS solver to find the equilibrium solution. So this is how we can set up a model for solution in GAMS. Now what we did to make it dynamic is that we started a loop. So we will solve the model in every single time period what we defined before, with some different framework conditions like labor migration and capital accumulation, or when we introduce some interventions, those actually will change the circumstances. I will store the solution of the variables in intertemporal parameters, and what we need to do again is to define the new set of capital stock based on depreciation and savings, and define labor migration based on a simple migration function based on wage differences between regions. So if we have everything, then I show you how you can do the simulation, the scenario round when you have an intervention in the system. So in this case I define the shocks to start to happen in time period 3. So the time period T when we enter the shock, but actually those shocks will impact the system in time period 4 because the solve statement stands before this if statement. Which means that, for example, we can introduce infrastructural development. In this case, there will be a change in the transportation cost, a demographic change when we, for example, change the labor supply in regions, or we can define, for example, a technological shock intervention when we introduce a shock to a share parameter. In this case, we can call it, for example, total factor productivity in one region. We increase it and see the expected result of a simulation like that. So now let me go back to the beginning of the file. So you can see that the scenario switch is set to 0. So if we run the model, it will be a baseline run without any interventions. So this shock will only be introduced to the system if the scenario switch is set to unity. Okay, the last thing what you can find in the file is basically writing the results back to Excel to some predefined sheets, baseline sheets and scenario sheets. Okay, So now you have everything what you need to know about the files in GAMS. So let me go back to calibration, and now I'm going to show you how to run these files. So first what I need to do is I'm going to use the command line here. So what I can do is that I type in s equal to s1, as you can see here. This means that when the calibration is done, we will store the data of the calibration within GAMS, and this data can be used in the simulation file. So s means save and r means read. So I'm going to read s1 file in simulation as well. So let's hit run in the calibration. So calibration is done, and you can see here the display, and you have many different things here. L01, K01, etc. They are going to be the check for our calibration. When they are very close to zero, they are almost zero, it means that calibration is okay, or at least what we can tell right now, it should be okay. When we have the simulation file, now I set the scenario switch to 0, so we will have a baseline run. In this case, what you have to make sure that you close the Excel file, otherwise GAMS cannot write anything to Excel. So I hit the solution, run. Now GAMS is working on it, and it finished the problem. So in this case again, we can look for the display, and we can look for the walrus. The walrus is going to be a parameter which will check whether the walrus law is true or not in case of a model. It's a CG thing, so we will have the same number of equations and variables, and if we have a numerator, then one of the equations doesn't have to be included in the model. Walrus will check whether this equation will be balanced even if it's taken out of the model. So if it's 0, it means that our model is kind of okay. So in this case, what you can see is it's okay. Now you can go back to the Excel file and see the results in it. I don't want to do that right now because I'm going to include shock right now. So I change the scenario switch to 1, and if you remember, down there we defined a shock, a technological progress shock, which will be included in the model. Now I hit run, GAMS will solve it, and at the end of the file GAMS will write the results to the Excel file. So now I will open the Excel file and see what happened to the system. So basically it's a positive shock. We changed the TFP, the total factor productivity, in region 1 in a positive way, so we assume that there will be many positive changes in the system. So we will have the baseline numbers, the scenario numbers, and the difference between them is going to be the result of the model. So we have the regional values for quantities and prices, and we have national ones, and we have the trade values over here. So as I mentioned before, these shocks will start from time period 4 or time period, because we introduced them in time period 3, and yes, it's kind of visible that region 1 will be a benefit there in this case because the technological shock happened there, but in terms of consumption, all the other regions and the consumers in those regions will feel a higher level of welfare because technological progress, lower prices, and higher level of consumption. Of course, a CGE model, especially a spatial computable general equilibrium model, is capable of describing the impact not just at the national level, what you can see here, but also at the level of the regions. So this way we can have a much detailed information about the expected results of the different kinds of shocks. Again, I don't want to really go into deep details of analyzing the impacts of this technological shock, since all the numbers in the model are fictional. Again, it's just an illustration of how you can do it, and what you can do with the computable general equilibrium model in GAMS. Okay, so this is what I would like to, what I wanted to show you in GAMS. So we have the structure of the model, we have the data for a GAMS model, we have calibration, simulation. Now we know how to write the results to Excel. From this point you can use different shocks, you can try to go and explore the input mechanism behind the model framework. That's really how you can know to the model that you have built for yourself. So thank you for the attention and goodbye.